The background worker control simplifies the process of building a multi-threaded application by abstracting away the complexity of creating delegates, worrying about marshalling, and the other details that go along with building multi-threaded applications. So the background worker control is great for allowing your application to be responsive to the user while taking on some long-running operation in the background. And I've created this little example to demonstrate a long-running operation that we delegate to the background worker control. Meanwhile, it's feeding back to the user feedback and allows the user to still interact with the application. And that long-running process is the lookup of all of the bookmarks that we have in the My Favorites directory that we may have created with Internet Explorer, and making sure that those hyperlinks are still valid. Now notice whenever I click this button that we'll get an update in our progress bar. We'll get an update in our little label within our status strip. We'll get an update about the progress within a list control, and we'll still be able to interact with the application. So let's go ahead and click the button, and you'll notice that I'm still interacting with the application by opening up menus and things of that nature while the application was running. And you can see that in this instance it found one page that no longer exists that we have bookmarked. So I was able to write this application without really having to worry about the details of a multi-threaded application. I simply relied on the function that was provided to us by the background worker control. And the key to the background worker is a series of 3 events that are provided. And we handle these events writing code to respond to 3 different states of the long-running process. There's do work, progress changed, and run worker complete. Let's start with the do work event. This is where you'll write the code that will run in the background. So your long-running process will be initiated here. This event is fired whenever you call the run worker async method of the background worker control. So whenever you get ready to run that long-running process, you'll make a call to the sample background worker dot run worker async. And in our case, we wrote that behind this split button control. So let's take a look at that event handler here. You can see that we do some initial processing to determine the selected directory, and then the final line of code in the button click event, we call the run worker async method of our sample background worker control. This will fire off the do work event, as you can see handled here, and we'll come back to this in just a moment. Also notice that we're passing in the value of selected directory. So we can pass in optional arguments that are necessary in order for our long-running process to work. Whenever we handle the do work event for our background worker control, it'll be running at that point on a separate thread and will not have access to any of the controls from the original thread. So all the information that's needed by this do event handler has to be passed into it. Now you might be wondering, if that's the case, then how were we able to update the label on the status strip and the progress bar? Well, we have an operation, and we'll show just a moment how we can essentially come up for error and report back to the original thread what our current progress is. And so let's take a look at, again, the events for our background worker control. The second one is progress changed. So as the background process is running, you can supply information such as textual updates or progress bar movement as the background process is continuing to work away. This progress changed event is raised each time you call the report progress method of the background worker control. So this is the way that we essentially come up for error and report back on the progress. So let's take a look at the do work method, which is an event handler for our background worker do work event. Here we're going to get an array of files, and then we're going to go through each of the files for a given directory, opening up each file and reading it line by line until we find some qualifying text. We'll retrieve a URL from that file, that hyperlink file. Then we'll go out to the web and we'll try to connect to that website given the URL. And if we're successful, we'll build a string and save it into a local variable called status text. If we're unsuccessful, we'll build the status text local variable again, but include this little 404 message at the very bottom of it. Now, right before we move on to the next file, we'll want to report the progress back. So we're going to update the current counter and use that to calculate the current progress. So based on how many files there are, we'll use our counter to determine the percentage of completion. Then we'll take that value along with the status value that we want to display in the status strip and in the list control and call the report progress method of our background worker control. This again allows us to essentially come up for air and calls the progress changed event which we're able to handle. So this information, the progress and the status text, as you can see, and we'll just hit the spacebar here to open up the IntelliSense, it gives us the ability to report back the percent progress and also something called a user state. So any current state information we can pass back to the original thread. And so whenever we get to handle the progress changed event, that information will be passed to us in this object E, which is of type progress changed event args. We can get to this status text variable, this object state information, or rather user state information, by using the user state property of our progress change event argument. We'll use that to add an entry in the list box and in the status label, and then we'll update the progress bar's value with this first value, E dot. So this will happen each time that we call the report progress method of the sample background worker. So we'll continue to loop through our do work little loop here until it is finished and it falls outside of the scope of the do work event, at which point the last event is invoked, which is run worker completed. So when the background operation is finished, this event will fire. In other words, when the do work method is no longer executing, this event fires. So in this case, what we can do is kind of set things back to a normal state. What we're doing here is just reporting to the user that we're finished, and we set the progress bar value back to 0. If we needed to do any other cleanup, we could do it right here. If we want to report the progress back, it's important that we set one property of our background worker, and that is that the worker reports progress equal to true. As you'll see, there's another property that we haven't demonstrated here, but we could enable, and that is worker supports cancellation. Currently that's set to false. However, we could set that to true and then allow the user to cancel the do work operation using some button on the toolbar or some menu option. So in closing, the background worker control is a great introduction into creating multi-threaded applications without having to worry about the complexity and all the details of writing multi-threaded applications.